Hello, my dear students. Today we are going to continue chapter 5, which is organic chemistry. We are going to discuss the second part, which is hydrocarbon derivatives. We are going to discuss the functional groups and their compounds, and we are going to discuss alcohols in details. We are going to discuss their nomenclature and preparation and physical properties. So let us start. Hydrocarbon derivatives. The functional group. It is a group of atoms which distinguish the type of compound and is attached to one or more alkyl or allyl radicals. The following table will show the class and general formula of the compound and its functional group. So alcohols have general formula ROH and function group hydroxyl group, and example for it is methyl alcohol CH3OH. Second class we are going to discuss is phenols, have general formula RAROH and function group also hydroxyl group. For example, phenol C6H5OH molecular formula. Next class here we are going to discuss is ethers, have general formula ROR and functional group ethereal group oxygen as between two radicals. For example, dimethyl ether CH3OCH3. Next class we are going to discuss is aldehydes, have general formula RCHO and have function group formyl group or aldehyde group CHO. For example, acetaldehyde or ethanol CH3CHO. Next class we are going to discuss is ketone, have general formula RCOR, have function group carbonyl group CO, and example for it acetone CH3COCH3. And next class we are going to discuss is carboxylic acids, have general formula RCOOH and functional group carboxylic group COOH. For example here acetic acid or ethanoic acid CH3COOH. Next class here esters, have general formula RCOOR, have function group ester group COO group. For example, ethyl acetate ester has structure formula CH3COO C2H5. Next class, and we are going to discuss it, amines, has general molecular formula RNH2 and function group amino group NH2. For example here ethyl amine C2H5NH2. Now we are going to discuss alcohols and phenols. They are organic compounds containing one or more hydroxyl group. Aliphatic alcohols, the hydroxyl group is linked to an alkyl group. For example, methyl alcohol CH3OH. Phenols, the hydroxyl group is directly linked to benzene ring. For example, phenol C6H5OH. the formula origin of alcohols and phenols. As derivative of water, by substitution of hydrogen atom of water by alkyl or allyl group. For example, here HOH, by removing hydrogen and replaced alkyl group ROH, it will be alcohol, or replaced by aryl group, it will be IROH for phenol. For example, HOH, by removing the hydrogen, we put C2H5, it will be C2H5OH ethanol, or we put C6H5 phenyl radical, it will be phenol C6H5OH. Also can be treated as derivatives of hydrocarbons by substitution of one or more hydrogen atoms by one or more hydroxyl group. As alkane, we replace the hydrogen atom by hydroxyl group, it will be ROH, it will be alcohol. Or the aromatic hydrocarbon, replace one hydrogen by hydroxyl group, it will be AROH, phenols. For example, CH4, removing hydrogen and replacing OH, it will be CH3OH methanol. Or benzene, removing hydrogen and replaced by hydroxyl, it will be C6H5OH phenol. Now we are going to discuss in details alcohols. The nomenclature of alcohols according to the alkyl radicals, by adding the word alcohol to the alkyl group such that C4H9OH is butyl alcohol, C5H11OH is bentyl alcohol. According to IUPAC system, by placing the OL suffix in the corresponding alkane instead of the ending E, such that this CH3, CH2, CHOH, CH3 molecule as a name of alkane, longest continuous chain, 4 carbon atoms, so it will be butane, replacing E by OL, so butanol, and the hydroxyl group at carbon number 2, so it will be 2-butanol. Another example here, the molecule here has longest continuous chain, contain 5 carbon atoms, so it will be pentane. And at carbon number 2, the hydroxyl group, so replacing E by OL, pentanol, and it will be at carbon number 2, so 2-pentanol. My dear student, notice that in case of common nomenclature, the name iso is used if the carbon atom of hydroxyl group is attached to 2 carbon atoms. As shown on the screen here, it will be isobutyl alcohol, and here isobentyl alcohol. Now we are going to discuss the classification of alcohols. Monohydric alcohol, alcohols that contain one hydroxyl group. For example, methanol, CH3OH, ethanol, C2H5OH, and we are going to discuss the classification of monohydric alcohols. Primary alcohols, the carbonyl group, which is carbon attached to hydroxyl group, is attached to one alkyl radical and 2 hydrogen atoms. As shown on the screen, primary alcohol, the alkyl attached to carbon, and this carbon attached to hydrogen atom, and so it will be a primary alcohol. For example, CH3, CH2OH, it will be ethanol. Secondary alcohol, here the carbonyl group is attached to 2 alkyl radicals and 1 hydrogen atom. Here as secondary alcohol, to the carbon atom of the carbonyl group attached to two alkyl radicals. For example, CH3CH, CH3OH, so its name, UPAC name is called 2-propanol, but common name isopropyl alcohol. Tertiary alcohol. The carbonyl group C contain hydroxyl group is attached to 3 alkyl radicals and no hydrogen atoms. The tertiary alcohol here, as shown on the screen, the carbon of that carbonyl group has 3 alkyl groups attached to it. For example, here as shown on the screen, so it will be 2-methyl 2-propanol or tertiary butyl alcohol as common name. Now we are going to discuss the dihydric alcohol. This alcohol contains 2 hydroxyl groups. For example, CH2OH, CH2OH that we know ethylene glycol. Trihydric alcohol, that alcohol contains 3 hydroxyl groups. As shown on the screen, CH2OH, CHOH, CH2OH, it will be glycerol. Now we are going to discuss the last type of classification of alcohol is polyhydric alcohols. This alcohol contains more than 3 hydroxyl groups. As shown on the screen, CH2OH, CHOH all 4, CH2OH is called sorbitol. Here, my dear students, we are going to discuss in details ethyl alcohol or ethanol. The preparation of ethanol by alcoholic fermentation of starch and sugar materials as sugarcane, beet, and maize. My dear student, 20% of ethanol is produced all over the world by alcoholic fermentation process. In Egypt, the ethanol is prepared by alcoholic fermentation of molasses or sucrose. The fermentation process takes place by addition of yeast to molasses, where ethanol and carbon dioxide gas are formed as following. Sucrose plus water is called hydrolysis. It gives glucose and fructose, which are 2 isomeric molecules. Then glucose here by yeast fungus, and it produces the maize enzyme. It gives ethanol releasing carbon dioxide gas as shown on the screen. The second way of preparation of ethanol is hydration of ethene. My dear student, any alkene on hydration, it can produce alcohol, but its type will be different according to the type of alkene used. Here, hydration of ethene gives the primary alcohol. Here, ethene is obtained from a thermal cracking of long-chain petroleum material, and so petroleum product by cracking gives ethylene, and then ethanol can be obtained from catalytic hydration of ethene with concentrated sulfuric acid as catalyst at 80 till 110 degrees Celsius. As the equation proceeds on the screen, CH2 double bond CH2 plus H2O, here the presence of sulfuric acid from 80 till 110 degrees Celsius gives the ethanol. So we have good reason in this point. Ethanol is considered as petrochemical compound produced from petroleum because it is obtained from catalytic hydration of ethene that's produced from thermal cracking of long-chain petroleum materials. My dear student, notice that ethene is the only alkene which gives the primary alcohol by catalytic hydration. while the other alkenes give secondary or tertiary alcohol according to applying Markovnikov rules. For example, propene plus water on hydration in the presence of concentrated sulfuric acid from 80 till 110. Here we apply Markovnikov rule, the hydroxyl group attached to the carbon poor in hydrogen, and so it gives 2-propanol as shown on the screen, CH3, CHOH, CH3, which is secondary alcohol. Here 2-methyl 1-propene. On adding water and sulfuric acid as catalyst, 80 till 110 degrees Celsius, it gives 2-methyl 2-propanol, which is tertiary alcohol, as shown on the screen. Now the third way, which is general method, it is the hydrolysis of alkyl halide. By heating the alkyl halides with aqueous solution of strong alkalis, where the halide radical is replaced by hydroxyl group and the corresponding alcohol is formed. Here, as the equation proceeds on the screen, the alkyl halide plus potassium hydroxide in aqueous solution, it gives the alcohol and releasing potassium halide, where R is the alkyl radical and X is the halide radical. All types of alcohol may be prepared by this method by using the corresponding alkyl halide. That means when reacting ethyl bromide with potassium hydroxide aqueous solution, it gives ethanol and releasing potassium bromide. Here ethyl bromide is primary alkyl halide, as the halogen atom is attached to carbon attached to one alkyl radical, and so it gives alcohol where the carbon of carbonyl group attached to one alkyl radical also. But on using 2-bromopropane with potassium hydroxide in aqueous solution, here the alkyl halide, here halogen atom is bromine attached to carbon joined to two alkyl radicals. So on hydrolysis, it gives 2-propanol, which is also secondary monohydric alcohol, as the alkyl radicals here, 2 alkyl radicals are attached to the carbon of the carbonyl group. And on reacting tertiary butyl chloride with potassium hydroxide in aqueous solution, this is tertiary alkyl halide, as the halogen atom attached to carbon joined to 3 radicals, and so on hydrolysis, here it gives tertiary butanol, where the carbon of carbonyl group is attached to 3 also alkyl radicals. My dear student, notice that the ability for hydrolysis depends on the ease of displacement of halogen, as iodide more than bromide more than chloride. Now we are going to discuss the converted alcohol or red spirit. It consists of 96% of ethanol plus poisonous substance, for example methanol, that causes madness and blindness, and bad smell substance is produced. Here, my dear student, the contents of this type of alcohol, which is called converted alcohol or red spirit, contains mainly percent the ethanol and other additive substance, poisonous substance, methanol, and bad smell pyridine or ponyl, and also coloring dye. My dear student, notice that these additives make it poisonous, cheap, and unfit for drinking, only used as fuel. So we are going to discuss the general properties of alcohols. They are neutral colorless compounds. First member of alcohols are light liquids completely miscible with water. Middle members are oily and heavy members are solids and waxy substance. We have give reason in this point. Alcohols are highly soluble in water. Due to the presence of polar hydroxyl group, which forms hydrogen bonds with water molecules, as shown on the screen, the hydrogen bond is formed between two molecules. One is alcohol and the other is water due to the polarity of the hydroxyl group. Another give reason. Alcohols have higher boiling point than alkenes due to the presence of polar hydroxyl group which forms hydrogen bonds between the molecules of alcohol and each other that need more energy to be broken, as the polarity of hydroxyl group forms hydrogen bond between its molecules. The factors affecting the solubility of alcohol in water. Solubility decreases with increase of their molecular weight. Solubility increases with the increase of number of hydroxyl groups in the molecule. So we are going to discuss some questions. Choose the correct answer. Organic compounds are formed by replacing one hydrogen atom or more in alkanes by OH group called alcohols, phenols, ethers, alkenes. If you think about it, yes, it will be alcohols. 1-propanol is considered from what kind of alcohol? Is it secondary monohydric, primary monohydric, primary dihydric, tertiary monohydric? If you think about it, yes, it will be primary monohydric. Alcohol CH3, CH2, CH2OH is considered from what kind of alcohol? Is it primary, secondary, tertiary, alkene? Here, my dear student, the carbonyl group attached to one alkyl group, so it will be primary alcohol. Next point. Alkaline hydrolysis of 2-bromopropane gives what? Primary alcohol, secondary alcohol, tertiary alcohol. Yes, the answer it will be secondary alcohol. Catalytic hydration of propene gives what? Primary alcohol or secondary alcohol or tertiary alcohol or dihydric alcohol? If you think about it, yes, it will be secondary alcohol. Next point. Boiling point of glycerol is higher than that of what? Ethanol, propanol, ethylene glycol, all of them. If you think about it, yes, it will be all of them. One of the following alcohol is secondary alcohol. CH3, CH2, CH2OH, CH3, CH2O2, CHOH, CH3, CH3, CH2O2, CH2OH, CH3O2, CH, CH2OH. Yes, if you think about it, yes, it will be number B. The following reaction, C6H12 yeast, gives ethanol and carbon dioxide is called what? Polymerization, esterification, saponification, fermentation. If you think about it, yes, it will be fermentation reaction. Next type of question. Write the scientific term. Aliphatic organic compounds having a hydroxyl group in their structure. Yes, the answer it will be alcohol. Aromatic organic compounds having a hydroxyl group attached directly to benzene ring. If you think about it, yes, it will be phenols. Alcohols in which the carbonyl group is attached with two alkyl groups and one hydrogen atom. If you think about it, yes, it will be secondary alcohol. Organic compounds having CH2OH group in their structure. If you think about it, yes, it will be primary alcohol. Alcohols in which the carbonyl group is not attached to any hydrogen atoms. If you think about it, yes, it will be tertiary alcohol. A type of bond in which is responsible for the solubility of light alcohols in water and the increase in their boiling point. Yes, hydrogen bond. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.